Okay. Gulani ma'am, please continue.
Yes, good morning everyone. Am I audible?
Yes, ma'am. Yes.
A very warm welcome to today's webinar on industrial automation organized by Sahakar Maharshi Shankarrao Mohite Patil Institute of Technology and Research, Shankarnagar, Akluz. This morning, we are indeed honored and privileged to have a young and dynamic personality who will share with us their views and experience on their topic industrial automation. Mr. Daresh Jadhav, freelancer Daresh Electrical in Pune. He did BTech in electrical engineering. He is PLC programmer automation engineer in Daresh Electrical in Pune. He has been worked more than 3 years in the field of industrial automation. During his working career, he assists students with the project. He is always in the front line when it's come to motivation and guidance. Yeah, and I'm confident Mr. Daresh Jadhav direction will assist participants to create a brighter career industrial automation. Without further ado, now I invite Mr. Daresh Jadhav to take a charge of today's webinar. Thank you. Daresh sir, please continue.
Thank you very much, Krishna ma'am. Thank you, HOD sir. Also, Dhanashri Bhadke ma'am, to organize such a good webinar. Also, I would like to thank Sahakar Maharshi Shankarrao Mohite Patil Institute of Technology and Research, as they are focusing on emerging trends in industry after pandemic. So today I am going to share my views on industrial automation. Ma'am, please can you stop sharing your screen so that I can share my screen? Am I audible?
Yes, yes. Preeti ma'am, stop sharing screen. Okay, you can share now screen.
Yes, yes. Is my screen visible to everyone? Yeah, it is, I guess.
Yes.
Okay, so first of all, I would like to is my PPT visible to everyone?
Yes, sir.
Yeah, yeah. Okay. So firstly, today's topic is industrial automation. Myself, Daresh Jadhav, and I am a freelancer PLC programmer as well as automation engineer. So basically, what is an automation? We will start from ground. So automation meaning auto means self and machine means motion. So self plus motion is equal to automation. Right from agriculture to space technology, in everything we need the automation word and automation to get the results 100% and with greater efficiency. The automation necessity of manufacturing industry to serve the today's global competitive market means whatever there is in a globally available over there in a competitive market, it should be fast and it should be bold enough to capture the market with the rapid movement. So we need automation in each and every field. So what is an industrial automation? Starting with that, automation replaces the human involvement with the use of logical programming commands and powerful machineries. The industrial world is facing many technical challenges which increases urgent demand for good quality of products. The industrial automation plays key role in solving the requirement of company. Means what happens most of the time, the machineries are strong enough but not are fast enough or not are automated enough to deliver the product in specific time. So there is a need of automation on that machine to give the product with 100% quality as well as with efficiency of the human involvement. After that, we will focus on second point, which is like the urgent demand. Means as you can see, the growth of population is leading to the growth of demand of each and every product which we are consuming in our day-to-day life. Let's start with a basic example of iron, like press, which we use to press our clothes. So basically, in that also the automation is involved, which is a temperature sensor. So each and every part there is an automation in this society. The third point is that to improve the company standards, and after that To solve all the problems, we need industrial automation. Here is a basic demonstration, means in which I have elaborated. As you can see, there is Charlie Chaplin working hard to do all that screws tight, and eventually here you can see the robotics which is doing accurately and also doing it very efficiently. So this is the difference in automation. Means first of all, whichever things the human needed to do, now the robots are doing that. Only we need to do is do monitoring work in this, and also the supervisory work to do in this. So there is minimum human efforts and maximum product quality. See, as you can see that at eventually the Charlie Chaplin will get tired and eventually he will go inside that mill. If you have all seen that episode, how funny it was. But apart from the funny part, it is also very important to get all the industrial standards. Means if he misses any of the part, at that time it will go loose for the forward and it will be loose forever till the end product. But the robot, in the case of robot, it is not happening the same. The robot will sort out each and everything. As you can see, there is more complex operation involved in this rather than the easy operation, but robots are doing very easily. This is the pneumatic gripper, and this is a robot which is controlled by our PLC system. So need an importance of industrial automation. First of all, to reduce the direct human labor cost and expenses. So whenever there is a human involved in any of the operation, there is a labor cost, and human comes with a time limit. Whenever the human interruption is there, there is a time limit. Means the human will work can work only 12 hours, 20, 16 hours, not more than that. If you push more than that, then there will be the quality failure in that case. So, and if you switch to the automation scheme, industrial automation scheme, in that all the robots, all the parts will work for 24 by 7, and only you need to do is a preventive maintenance regularly. There will be no breakdown maintenance as well if you do preventive maintenance regularly. So the human cost and expenses are reduced in this case only for monitoring purpose. Means only if there is any labor on that line. So from start to end of any product, if there is any human labor, only one human labor is enough to carry out the whole operation. In this case, if the whole automation if the whole line is automized. Industrial productivity, second point. So all the productivity which we are focusing on will keep on increasing again, rapidly. After that, consistency of the process as product. So whatever there might be the composition or whatever be the consistency, in that case the product will deliver its 100%, and all the quality checks will be improved in that case. Next is improve the product quality. So what happens when there is a human intervention or there is a manual operation? In that case, if the human or that labor gets tired, in that case he will start to like complete his job only for the target purpose. He will not complete his as per the quality requirements. So in that, the quality will also get increased if we implement the industrial automation. To reduce the manual checking, means what happens if there is some, suppose if there is a product, if we consider our bike, our electric bike. So in that case, if there is a manufacturing of electric bike and there is an assembly line for an electric bike and everything is done automation, in that case every wire will be tight in that moped or that bike. Everything will be okay. But if there is a human intervention, so if it is done built manually, then you will need to check each and every wire, you will need to check each and every fuse in that electric bike. Apart from that, in automation you will be sure shot that every camera is working proper, every sensor is working proper, then your product is eventually giving you the 100% okay part. So manual checking is reduced in that case. To raise the level of safety, so what is most important is to increase the safety. So what happens, there are big hydraulic machines, pneumatic machines. In that case, the like it is huge actuating parts which are very dangerous for humans if they collide with them. So for that we can use safety sensors, safety curtains, and everything can be implemented in this automation scheme. So this is a basic need and importance, and there is also a thorough definition of industrial automation. I will read it out. Industrial automation is the control of machinery and process used in various industries by autonomous system through the use of technologies like robot and computer software. Means if there is each and every autonomous system connected each other by using this industrial automation system and implemented by using sensors and actuators. So eventually, like, there are computer softwares, like there are programming softwares, after that there is robotic software, the robotic communications and all. There are different aspects in which robot and the machine and the computer speaks to each other. There are different protocols like rs232, ethernet. After that, the basically everyone knows ethernet also. So these are the need, importance of industrial automation and definition. If anyone has any doubt, please feel free to ask me, interrupt me. There will be no issue in that. If anyone has any doubt or any questions. So this is automation hierarchy. So this is a pyramid of automation hierarchy. So this is like all the theoretical part which I'm going through right now. After the theoretical part, there is also a programming part which I'm going to demonstrate a short programming part also. That is PLC programming and HMI programming, in which I will show you the short demonstration that how all system works. We will cover up all the theoretical part in like first half of my session. So like this is in a pyramid of automation hierarchy, and you can, as you can see, there are 5 levels in this. The first level is field level. Field level means where actually the manufacturing take place and every part is getting assembled and all the workers are working over there. Means like here you include sensors, actuators, transducers, transmitters, temperature sensors, thermocouples, everything which is connected to the machine that is involved in this field sensor. Means basically, like if I give you the example of field level, at that time whenever you enter a dark room, or suppose your hall at night and it is dark, so first of all you will need to switch on the light. After that the light will get turned on. So basically the switch is and a field level device. This is a very very basic example which I have given you to compare all the field level devices. So as the switch, manual switch, it is like our switch is a manual switch. So second is in a control level. This is in a bit advanced level. So as you go upwards in the pyramid, you get more advanced level of things. So in this control level, you include PLC, PID controllers. After that, DCS. PLC means programmable logic control. After that, DCS means distributed control system. So what does the PLC do? PLC has its own memory, own devices, set of devices, that is input devices and output devices, which are configured on the PLC program. After that, they are controlled and monitored by that PLC. So as if there is a sensor or something, you take that input. Means whenever these field devices are connected to this PLC, at that time you take this input, process it and give the output. And DCS is that plant which does not controls an a single system. It controls the various PLCs or else various systems. That is called as DCS. Next level is third level, that is supervisory level. That is SCADA, historian, and HMI. So SCADA is basically a system means which give you a visual effect of all the system which are running in the plant itself. So let us consider a packing plant of milk packaging plant. In that milk packaging plant, for that you will need an milk. After that you will need an a polythene which will seal the milk inside that, and after that it will be delivered to market itself. So in that, how much production is carried out, after that how much liter of milk is utilized, after that every point is concluded in SCADA and historian, and you can see everything on HMI itself. So it is in a supervisory level where you have to maintain all the things. And after that there is an MES system which is called as manufacturing execution system. That is a planning level. So basically, if we see like there is a lot of trend in industrial, like there is an IT sector and there is a normal sector. If we compare, so these two are like IT sector, like where all the computer engineers sit in their cabins and all monitor, do all the softwares related to that and everything. This thing is all often a desk job, and this is everything often a field job. Means everything is done on the field, and this can be done remotely, which is called as planning level and management level. That is ERP and MES. They are independent two subjects also. Means each and every system, each and every level is having each and every subject. Means totally a huge subject which is very vast to study in industrial automation. So basically, in the automation hierarchy, first is in field level. So I gave you the example of switch. Apart from that, here I have given some GIFs to show you exactly what is the field level. In this, as you can see, there is a motor, there is a switch, transmitter, and after that there is a sensor. So I will read out the points. It is the lowest level of an automation hierarchy, which includes the field devices like sensor and actuator. So these two are actuators, and this is the sensor, basically. It contains AC or DC motor, relays, valves, sensors, barcodes, etc. So this is a basically basic valve which is like operating according to our requirement. Whenever if we trigger the output, if we trigger the output, it is getting turned off. If the output is not triggered, it is flowing continuously. After that, the main task of field devices is to transfer the data, process and machines to the higher level of monitoring and analysis. So like we collect all the data from the sensor, give it to our PLC and DCS system, and then it is processed over there, and after that we get the output. So basically this is the field level. I hope so everyone are getting what I'm saying. If anyone is like having any kind of questions, basic also questions, you can feel free to ask me, no issue in that. Am I audible, ma'am? Anyone?
Yes, yes,
Yeah,
yes,
yeah.
yes.
Okay. So next in automation hierarchy, control level and supervisory and production control level. So in control level, this consists of various automation devices like CNC machines, PLC, DCS, robots, PID, etc., which take the process parameters from various sensors and perform the control technique. Means the basic element of this is process parameters. What are the process parameters in this case? In this case, process parameters are sensors and actuators. And like in this, like we have CNC machines, PLC, DCS, robotics, and PID. In robots, we have like robotic arms in this case. Like most of them are like imagining like robots means we have actual robots in that, but it is not the scenario in this case. We have the robotics arm or robotic gripper or something like that, which is like highly programmable and which can perform like various operation like pick and place, spot welding, arc welding, and everything. Basically most of the hazardous environment and welding or high temperature, we use robotic arms. Next level is level 3, that is supervisory and production control level. In this level, automation devices are monitored and controlled by HMI. In this, various functions are carried out like supervising various parameters, setting out production targets, setting of machines like start or shutdown. In this level, mostly DCS or SCADA are popularly used. Means, as you can see, the SCADA is implemented in control level as well as supervisory level. So in SCADA, DCS, in control level as well as in supervisory. So in DCS, like if we have to program something, we are using in control level also, and for supervisory also, to get all that data and communicate it with SCADA or any other HMI, we are using it in supervisory also. In supervisory, basically we have an HMI, that is human machine interface, in which you can see all the visualization of each and everything and each and every plant. So we have basically in that PID diagrams, PID flow diagrams, and everything is present in on the HMI, by which you can troubleshoot all inputs as well as the output, as well as you can carry out the manual operations, as well as by you accessing the code for each and every level. And basically whenever there is a production line, there is start to end process, start and finish. Means there are some kind of raw materials, after that there is some kind of finished semi finished goods which need to assemble. So that all setting, target setting and supervisory and machine setting as well as carried out in supervisory and control level. So last level, that is 4 and 5, is planning and management level. In this, the most important thing is MES and ERP. As you can see the below image, it is like versus image, in which I have shown you like to exactly how it works. So in ERP, you can see the various factors which are included, that is finance, sale, CRM, human resource, services, purchasing, delivery, inventory, everything is involved in ERP. Means all the management level related to that is included in ERP. And after that, MES means manufacturing execution system. In this reporting, after that SPC tracking, equipment interfacing, recipes, work instructions, resource management, everything is involved in this. So, like for example, if we take recipes, so it is in this recipes, as you can consider, there is like suppose there is a juice manufacturing plant. In a juice manufacturing plant, you have various inputs, like you have the lychee juice. After that, you have pomegranate juice. So for lychee juice and pomegranate juice, if you consider two fruits, in that case, for pomegranate, you will need another process time, another need of extraction, and another set of machines. And for lychee juice, you will need another set of equipments, another set of process, and another set of like outputs. So in that case, we make a specific recipe for that. In that recipe, what is the most important thing is that like you have pre-configured everything and you have to only select the exact same recipe. So if you are using production of lychee, if you are giving the raw material lychee, in that you have to only select the lychee plant, lychee production, and after that, if you are using pomegranate, you have to only use the pomegranate plant. So in that case, what happens most of the time, your time saving is 100%. You need not do to need you don't have need to do the setting again and again in that machine. The easiest way is recipes thing, and every resource management and everything is included. This is at a top level of industrial automation which manages the whole automation system. Means basically everything is carried out on field and everything, but all the management level, all the automation system is controlled or monitored in this 4 and 5 level. The task of this level includes production planning, customer and market analysis, order and sales. Means the most important thing is also in that case, like see, according to season also the season also the manufacturing will take place of the juices. So like market analysis, in this season the lychee fruit is like cheaper than pomegranate, then let's do the manufacturing of lychee fruit and do the stock of that. So this all analysis is done in MES and ERP. So far, anyone has any doubts, or shall I continue? Hello,
Anyone has any doubt?
any questions? Please feel free to ask. It is an interactive session. If you have any basic level of questions, you can feel free to ask, because it is like after the main aim of us is to focus the industrial automation after the pandemic. So whatever, if you are feeling left out or anything missing in this presentation, you can also ask me to elaborate that things. I will share with you also that all things. I guess no one has doubts.
I also think so, same. So please continue.
Yeah, yeah. Okay. So the next slide is basic components of automation system. After that, in this, there are input devices, controllers, and output devices that are actuators. So input, controller, and output. Basically, we will start with input devices. The input devices are sensors, transducers, manual switches, etc. These devices are either type of analog type or digital type. The sense the parameters like pressure, temperature, and give feedback to the controller. Means basically what is an input device. If we consider in a basic input device, priorly I have given you example to switch on the light. So to switch on the light, you need to press the switch. So that switch is called as an input device in this case. And there are another kind of input devices. This is the 0 and 1 operation, means only it toggles on or off. That is called as a digital type of input, and which is having a scale of a specific thing, that is called as an analog type of input. So which is varying from like suppose if we take 0 to 10 volt or 4 to 20 milliamperes, it is an analog input. So it has a specific range that is calibrated with that. See, suppose if we consider a potentiometer, in that potentiometer, if we press some amount of pressure, it will give the displacement, and that displacement is in 4 to 20 milliamperes. So I have to scale it down according to the pre-described value of that potentiometer. So everything in this input device is given to the PLC or to the controller, which is driven by an embedded system. Next basic component is in a controller. Controller is in a heart of an automation system. It may be PLC or an embedded system device. Controller handles the operating system, manages the memory, monitors the input and output, controlled output devices. So, like, what is a controller? Controller can be a PLC or an embedded system device. Mostly we know it as microcontroller. So embedded system device means in a microcontroller system. In that, like, you have a fixed set of program, you have fixed set of hardware, and nothing can be changed and nothing can be added in that. So that is called as an embedded system device. And apart from that, you have PLC. In PLC, you can configure as much as input and output according to the highest capacity of the PLC, and you can change the program. If you can change the program according to your requirement, and you can add or remove the output cards. Like for basic PLC, there are 256 inputs and outputs for a basic PLC, that are hardwired physical inputs and outputs, which can be configured on in a small amount of like on PLC. And there are also mini PLCs in which you can do like a 100 rung program, in which like it is very flexible for an like small applications, and like it is very easy to use this kind of communication in this system. So if we are going for an embedded system, in that, like, there is a technique of, like, somewhat we can say there is a hand twisting in this case. Means what happens most of the time, like in embedded system, you have to stick to exact what you have designed. You cannot add or remove anything in that. That is called as an embedded system, and PLC is kind of a flexible system in this case. Next is an output devices or actuators. So basically, actuation means to like have a movement in some specific way. That is called as an actuation. So the output devices are controlled by the controller as per the logic or coding, according to they are switched on or off. Output devices may be analog and digital. Same in this case also. What is happening, like if there is a tower lamp or something lamp, it is controlled by, like, it is giving an indication. If there is any failure in the industry, it is showing the red color. So it is called as an output device. Apart from that, there are relays. The relay control the motor operation, or an electrical solenoid. Apart from that, the solenoid may be connected to the pneumatic cylinder, or else an hydraulic cylinder or hydro-pneumatic cylinder. Every in each and every case, like, you use output devices. In this output devices, they might be digital or analog. In analog, like, suppose for example, if we go back in analog, I will explain you exact example. If you see this wall, and there is an 100% pressure, or else 0% pressure flowing through this pipe. But if you need only partial pressure, means only 50%, you need the actuation of this valve only 50%, then it is called as an analog kind of valve. So in this case, like, only 50% means you have to calibrate it, you have to scale it, and it will only give the 50% of flow, 40% of flow. According to your requirement, it will work. That is called as an analog kind of output. Means we can control it using PLC. So the next segment is different systems for industrial automation. Different system means like what we can use, like we can use PLC, HMI, SCADA, DCS drives, everything we can use. So like going deep into this, I would like to give you the demonstration related to the PLC and HMI. In this case, means what will be, like, I will give you the clear you will get the clear idea exactly how does a PLC work and what all languages and how it is programmed. So basically, for programming, I am using Delta ISP Soft, which is an open source software which you can get free on internet, as well as DOP Soft, which is also open source software, and you can get free it on free. It is free on internet, so you will like no need to pay any charges or anything. If you go to the Siemens or any other product, you will need to pay for that, and which is very costly in that case. So shall I start with the demo?
Yes,
Yes.
you can go.
Okay, no issue. So, like, this is the interface, like, as you can see, this is an interface that is HMI interface, and this is in a PLC programming software that is ISP software. In this, I am going to show you a basic demo of a ladder language in which I will show you on and off operation of it, like how it works exactly. So, consider this as switch push push button one. Consider this as push button one. After that, consider this as stop push button. After that, I will give you output. Suppose this is motor, and after that, I will latch this motor. So this is a very basic application. I am starting the motor from one push button, and I am stopping the motor from another push button. So this is in a motor. Let us consider. After that, this is an HMI screen. In this HMI screen, you have various elements like drag and drop elements, or else like you have various options. See, like you have momentary button, you have maintained button, you have set on, you have set off. So suppose like let's start with like doing a perfect screen. We will start with a perfect screen. So like we will start with webinar on industrial automation. After that, we can change your font. After that, we can change over here the scaling. Okay. So basically, I have written over here webinar on industrial automation. I will show you how exactly the screen will look on an HMI. After that, you can add a button. We will add for time being, we will add maintained button. We have used M0 tag over there. So we are using M0 tag over here as well. For this, we will use green color, and for state one, we will use red color. And for text, art, up. Okay. So this is a start button. We will copy the same button. So for to reduce the time, we will just change the tag and color as well. And we will link the tag M1, but it will be easy for us. Text is remaining. Okay. So as you can see here, I have used M0 and M1, and here also I am using M0 to start and M1 to stop. So this is very basic program. I think so you have gone through it like it is in a ladder language. And after that, I will start the simulation over here. I have pre-configured all these things so that it will not consume the time in between the presentation. If anyone wants more details related to it, you can approach me later on. Currently I am not using any kind of PLC or in any kind of hardware in this case. I am just using a simulation module So in this simulation, like there are various things which you need to pre-configure it. So let's start the PLC. As you can see here, there is a status of run right now. Okay, and there is an M0 push button, and as you can see, I have used NC contact over here. So why I have used NC contact, you will get to know. See, after that I have started. See, as you can see, this is an HMI interface which you will see on the site itself. So there are no other toolbars over here. There is only webinar on industrial automation, and after that there is only a start button and stop button. Means only this much set of program I have done right now. So only you can see that much only program over here. So you can do various programs in this. You can include all the pneumatic operations or all other hydropneumatic operations, all or other actuating operations using VFD and everything. So see, currently, if I push start button, see, it is in a push button. Okay, so whenever I am pressing it, at that time only it is energized, and when I release it, it is off. So it is in a push button. So whenever I push this button, at that time my output gets high. So it gets from 0 it goes to 1. And when I press stop button, means this is in an NC condition stop button. So as you can see, a current flow is always left to right in a ladder language, and ladder language is always read from top to bottom and left to right. This is a standard format of a reading or ladder logic or operation of a ladder logic. Whenever it starts from left to right and top to bottom only. So see, there is a current over here. It is now going through this latched contact to again motor. So it is in a latched contact. So whenever I'm pressing in a stop button, as you can see, when I have pressed stop button, at that time the contact is getting de-energized. So in this case, whenever it is getting de-energized, at that time your operation is complete. So this can be an automated operation also. So whenever you press start, at that time at the start operation, you can use an sensor which is an a proximity sensor, or else you can use an inductive sensor, or you can use a temperature switch. If in each and every case, like there is a different application, there is a different SPM machine. SPM machine means special purpose machine, designed for a specific application, in that case to increase the production of that machine. So this is a very basic program. In this, like you can do n number of programs. Like in this ladder logic, you can do like a huge ladder logic. And after that, in this HMI also, you can do each and everything. Means if you want webinar on an industrial automation, I have written only this much. So this is in a static text. You can also add a static image. You can add your logo. You can add your set of, like, you can do it very aesthetically. So basically, what is aesthetics? Like, to see you need to see the industrial standards and do accordingly to that. So this is an operation of start and stop. Anyone is having any queries or any questions related to this, you can ask. Hello, or shall I move to another logic? Anyone has any kind of questions? Hello, around about 40 people. Hello, am I audible?
Yes, yes.
Okay. Okay, so like this is a very basic example which I have given you right now. So let's do some complex operation. Like I have used two different buttons in this case, like start and stop. So like I will show you how. So suppose like you don't want two individual buttons, you only want one button, and that one button is push button itself. Okay, to start and stop the operation. It is only one button you have over here available. So what will you be doing? I will delete this button, and you have only this button. So you have to start and stop the operation on this button itself. So basically we will need to modify the program. I will show you. So in this case you can also use the M1. memory beat. So there are different kinds of beats in this. There are hard tags, there are soft tags. So what are hard tags? Hard tags are like digital input, digital and output, analog input and analog output are hard tags. And what are soft tags, which are internally programmed in the PLC, are called as soft tags. So I will give the rising edge to this. So we will consider this as memory 2. We will latch it. Okay, so this is in a specific output, and this is in only one push button. Once I press the push button, the memory should get on, and after that I will release it. And after the second time I operate it, at that time the memory 2 should get off. In that case, I will start the simulation. So you can also interlink with this tag. For time being, we will use none over here. We will need to download it to our PLC, which is in a simulation PLC, a simulation model of PLC. We will start the simulation. So as you can see, the memory 2 is off in this case. We will start the simulation here as well. Okay. Now, as you press the start button, this memory 2 is turned on. And after you press it again, it is getting off. Means like a TV remote in this case. Like TV remote, you have a power button. First time you press it, the TV gets on. And again, when the TV is on, at that time you press it, the TV gets off. So this is a basic example, like how you can do the automation in this case. See, M2 is getting on, M2 is getting off. So in this case, like I have done a small program to operate a single push button for a single output. And in this process, I have used two memory tags. So like this is and a descriptive example like how you can use it for each and every case. Like there is a different logics, like whatever you want or whatever you want to do the operation from this button, you can do it. So like basically there is also a timer operation, there is also a counter operation. There are lots of operation which can be carried out in this PLC itself. Suppose like if I press this button, and after that, after 5 seconds, I need to turn on that memory bit. I can also use that also. After that, if I want, after I turn off that button, after 5 seconds delay, it should get turned off. Everything is possible. That is T on timer and T off timer. Every timer can be implemented. Every counter can be implemented. Means there are like lots of AIPs in this case. Like as you can see, there are lots of means n number of AIPs in this case. For each and everything we have like call jump operation, everything. See, in basic instructions you have pulse, bait out, double beat out, beat set, double beat reset, everything. TMR means timer, counter. After that, this all MC and MCR for auto related operations. Means like n number of instructions you have over here. Each and every instruction deals within a different API, and each and everything is like pre-programmed for a different output process. So everything on this, you can use servo motors. For servo motors, they can be incremental servo motors or an absolute servo motors. In that, you can use an pulse logic. So for servo motors, you can give n number of pulses. So servo motor, stepper motor, each and everything can be configured on this. Shall I show one more example, or like shall we stop for like question answer session? Like if anyone has any questions or like any doubts related to the industrial automation, like how to implement industrial automation, or is it useful for uh, any kind of another person? Hello.
Participants, if you have any doubt, please ask to sir. Be freely for asking about anything related to the industrial automation, PLC.
See, and most of them, like I don't know like from which background you are, but from any background you take, like from mechanical engineering, electrical engineering, instrumentation engineering, or else computer engineering, everyone can go in this industrial automation branch. So it is open to all. And there are various paths in this automation branch. Like you have like suppose if you are in a mechanical engineer, you can go in a design part related to an automation engineer, where you can design an actual machine and you can implement all the schemes and all the sensors over there. So if you are an electrical engineer, you can develop that PLC panel and everything. Means automation is an open branch where each and every engineer can implement. If you are an computer or an IT engineer, in that you can go to the MES and ERP section, in which you can develop the various kind of software which are very helpful for MES and ERP itself. So like this is a very important branch, like where you can do everything. Like my screen is getting in a hyperloop, I think so. So I will open the presentation. So anyone has any questions? Like we have like 5 to 10 minutes left for my session to complete. So like we have used the software that is ISP soft version 3.12 and DOP soft version 4.011. Any questions, like any doubts related, or anyone need to see any different logic? Like I want this kind of logic to see how exactly it works on PLC and HMI. I can show you right now, but don't just give in a complex one because it will take time. See, last 5-10 minutes I like kept purposefully for the question answer session, so that we will have a healthy communication. And apart from that, we will have like exactly what idea, like what I have discussed in this session.
Hi, sir. This is Praveen. So just one query from my side. So,
Okay.
so how how many numbers of command or how many logic we can create in a one network frame? Like, is there any end or we can create n number of logic in one network frame?
Okay. First of all, thank you, Praveen, for being attentive. That is very good to listen a question from your side also. Basically, see, in this PLC, it differs from PLC to PLC. You have a various set of various means lots and lots of things, and you can find it out in help itself. Like you have various kinds of instructions, you have timers, you have counters, each and everything. And it also depends on your application, for which application exactly are you programming. Suppose if you are programming for a servo motor, in that case you will use ddrvi command. After that you will use dsply command. So this all are like pulsating commands. So when you use a high speed commanding operation, at that time there is a different set of instructions. And this is a relay based program which I have shown right now. This is not a high speed program. This is a like moderate program which is used for a basic machine, and it is very basic operation, and it is kind of a manual operation now itself. So for that thing you will need to use a different set of programs. And like for logic, like you can logic use the logic, or you can create the logic in a huge parameters. Means like everything can be programmed over here according to your requirements and according to your input and outputs.
Yeah, thank you.
Okay. So like Sushmita Gandhi is having, can you give me one demo using timer? Okay. So like for timer, like let's suppose we are using M2 beat. After that, I will set this M2 beat. Why I am using set operation? Because like it is in a momentary operation. So for that, like timer is very important. Or else I can use it in this way also. TMR T0. Say I will say for 5 seconds. So everything is in milliseconds over here. Everything is in milliseconds in in PLC. So we are using 50 as for 5 seconds. So as you can see, I have enabled this using M2. After M2 gets energized, this block will get energized, enabled, and after that, after 5 seconds, the T0 timer will turn on. So LD T0, and suppose like we will see output M3. Okay, so this is output after 5 seconds. And this is timer 0. Since we are, and this which I am implementing this in green, they are only comment itself. They are not a program. That is in a comment. So each and every rung also you can give a comment. So over here, this is in a timer rung. Everything you can write over here. Label disclose. Okay. So we will see that further on later on. So after that, like M3, and for state 1, we will use red color. Means when it will get energized, it will get red. On, off. So right now I have used an indicator over here. After pressing this button, after 5 seconds, it will turn on to off. I will start the simulation over here. So I will so it is compiling the program. So that I will start the simulation of HMI itself. See, like at the start, when you will press start button on, it is on. See, as you can see, this timer is getting on, and after 5 seconds, this has turned on. And as soon as you press this button again, it is getting off. So see, after 5 seconds, delay of 5 seconds, there is a delay of 5 seconds. After a delay, it is on. So it is on. So it is showing an on indication over here. So you can program it according to your need and according to your requirement, whatever you need. So like basically, automation is everywhere in the world. Everywhere means basic to basic. Everywhere the automation use. You can also use it in agriculture itself. You can use it in a manufacturing plant, you can use it in production plant. Each and everywhere the automation is required, and whenever you use the automation, in that automation, like there is very much help and need to the human, as well as there is a safety. And if we use the proper machinery, there will be and less damage to environment as well. Means if you use the proper machineries for everything, the power will also get saved eventually. Most of the time, like suppose there is a worker on an specific production line, and at that time if he is like going somewhere far from the machine, he is keeping on machine at that time. But if you use this kind of timer, means if some worker is not working for like consider 5 minutes, after that the machine will get turned off automatically. So this is an automation which will help to save us the electricity itself. So like automation can be used everywhere. So like I hope so, like I have delivered whatever was the requirement of this session. So any questions from your side?
If anyone has any questions, please ask. Otherwise, put it in chat box.
Yeah, you can post it in the chat box as well. Is the chat box empty or like okay? So currently I am only seeing the hyperloop of my screen. There are no questions popping up.
Okay. Thank you so much, Darish sir, for your valuable guidance and the models that you have presented. Now I hand over the charge to the Miss Randhir Madam for vote of thanks.
Okay, good morning everyone. It is privilege and great joy for me to extend vote of thanks to all those who have contributed in one way or the other to make this webinar successful. Before concluding on behalf of SMSM PITR Aklus, I am Professor Randive express my sincere gratitude and appreciate to Mr. Darit Jadhav sir for giving their valuable time from very busy schedule. Sir, you have shared with us your knowledge and experience that guided us in the right direction. Also, I would like to thank our management, our founder, Honorable Vijay Singh Moite Patel, our president, Honorable Jai Singh Moite Patel, and our secretary, Rajendra Chaugule sir, and our principal, Dr. Indrajit Yadav sir, for allowing and motivating us for this webinar. Thank you all for invaluable contribution. With our prior permission, I declare that today's webinar is over. All
So,
participants kind
Yes,
ha,
thank you everyone. Thank you for being attentive. Thank you.
yes. All
thank you so much.
participants kindly note that feedback link is shared in chat box. So kindly fill the feedback form to get e-certificate on your registered email ID. Thank you.
Okay, so I hereby declare that the program is over. All fill your feedback form. Otherwise, you will not get e-certificate. Uh, HOD sir, so should we end the session?